Doctor, you are muting your mic.
Oh, I'm sorry. I've been talking to myself. My apologies. طيب يا شباب. So this is an announcement from the coordinator. He says in WebAssign there's a first homework set, and you'll find it under some location like 202 Math 102. This is a semester, and this is Math 102 homework. I don't know what that is. It's something like this. You certainly will find it there, and it's due on February 15. Okay, so this is your first homework assignment. تمام يا شباب, please do it, and if you have any problem, please consult with me. So is that okay now? Right, this is the first thing. Towards the end of this class, am I muted also? No. You hear me, yes?
Yes.
طيب, so towards the end of this class, we will have the first quiz. It will be on Blackboard, not WebAssign. And what I would like you to do is this. You see, gentlemen, I just sent you this document. I would like you to have your Blackboard in front of you, something like this, right? And you want to use your mobile phone from the side, so your face. This is Dr. Al-Khalifi, the coordinator himself. So I need to see your paper. You need to see your hands and your face. Very similar to what you did in Math 101. Okay, please. I don't want to spend time on this. You see, the more time we spend on this, the less time you have for the quiz. So once this is done, you should practice. I should have practiced this, in fact, right? And this is what he says. Now mute your mic, please. So this is his face, his hand, the table, and the laptop. And use your camera from the side to just and you must not really move out of this frame. So your camera must not go off. You must not move out of this frame, and everything is just nice and smooth. I took 2 problems from the textbook and then just put it there for you. So like, this is what I will always do. I will always take 2 problems from the textbook at the end of this section on the or exercises or examples or whatever, and I'll just pull them out, little modification with numbers and basically, and then I'll just give them to you. That's all. Okay, Shab, I hope this is all right. So don't panic, everything will be fine. The most important thing is that you have to conform to the regulations. Any violation with respect to taking the quiz is going to be very serious. Like you see, I only say probably this once. I don't want, and at least when I'm in charge here for this section, I don't want to see a student has been working really hard, scoring less than a student who's just not being very careless about the course. This is very serious to me. See, fair is fair, and I hope that everybody stays in picture. So you stay in that picture frame. You don't move. I want to see your hand, your laptop, right, your face, and your papers. And you must also, and don't give me these excuses like the camera is, there's a problem with my connection. See, these excuses must be resolved before the quiz time. Yeah. And also you must not use any other material. So you are only allowed to use a small calculator if you want to. Small, very simple calculator. That's fine with me. You can use also the calculator that is in your laptop, but I must see your screen. I prefer that you use the calculator that is in your laptop if you need it. I don't think you need that, yes, but if you insist, then I really don't mind. Now, not a calculator that will do integrals or whatever, that's not allowed. I don't want to put the lockdown browser, so I ruin your life with these stuff, you know. No, I just want to trust you. We want to learn something about this course. You see, this is a very, very serious course. I would like you to enjoy it, learn something about it, and then that's it. And do not panic. That all of you are going to be, inshallah, fine. Yes. Okay. So let's just now go to the to our.
Doctor,
Yes, sir.
do we scan our paper or just
No, no,
put
no,
the
no,
numbers?
no. Yeah, everything is going to be in Blackboard, so you'll have to input your answers there. Don't worry,
Okay.
it will be. Nah, man.
When the quiz will start?
So we will the quiz is going to end like 9:55. This is where the quiz is going to end. Now I'm going to stop everything at 9:20, right? And we will start. So this is about 35 minutes here. So we will start arranging ourselves. You arrange yourself in a minimum time. So you put yourself in the frame and everything is fine. Whatever time that remains, the quiz is going to take like 10 to 15 minutes maximum from you, right? So if you arrange yourself in a short time, then you have plenty of time to answer the quiz. If you do not, then whatever remains is your time the quiz. Even if it is 1 minute, then it's fine with me. This is your problem. Yeah, I shouldn't say a problem. This is your responsibility, probably, yes? So please try to help. Yeah, just adjust yourself, put your camera from now and make sure that everything is just fine. So we have minimum time and we will leave you plenty of time for the quiz and for you to be comfortable with it. And this is not a race. This is not a fight. This is something that I really need to know that you've been studying. That's all. This is what a quiz is doing. I need to know that you guys have been studying. I'm not going to give a hard time. And that's why I have no secrets. If you want to know where my quizzes are, just go to the end of the section or the solve examples in the book, shovel them, you'll find my quiz there. Absolutely. Okay, so we're starting the new section, which is the area between curves. So this is a small section, and I'm sure that you already know it. Suppose that I have a function here, and I want to find the area underneath this from a to b. Then all I need to do is just integrate this from a to b. This is f of x dx, and then that's it. Right? Everybody knows that. You see, if this function goes below the x-axis, all right, this is a and this is b, then what you actually do, this is going to be negative, this is going to be positive, and if you put the integral here, this is f of x dx, then this gives you, doesn't give you the area, it gives you the net signed area, which could be negative. Yes, this is what we agreed on last time. Now, if I'm just asking you for the area doesn't mean that, for example, let's say that I have the sine curve, right? From 0, let's say, to 2 pi. And if I am asking you for the integral, this is 0 and this is 2 pi. If I ask you for the integral, let's say the integral from 0 to 2 pi, this is the sine x dx, right? Then this is exactly 0. And the reason why this is 0, because this is positive, however, this is negative. Okay, so this is positive and this is negative, right? And then we'll eat up themselves and then we'll just get an answer. But this is not what the area is. The minute that you hear this interesting word area, it means the following. It means that you have to do this from 0 to, this is a pi, 0 to pi, and then you have the sine x. This is regular, yes, right? Because what you're doing with this is that you are calculating this, yes? So this is fine. And now you want to calculate this part here, right? Then what you do actually is that you have to multiply this by a minus sign. So this is 0 from pi to 2 pi of sine x dx, because the answer is going to be negative, and then you need to multiply this by a minus sign. So this is going to be positive. So this is already negative, and we have a minus sign, so this is positive. So actually you will get like 2 times the area from 0 to pi of sine x dx, and this is what we call the area. They think of the area as a piece of land. So if you have a piece of land in here, this is your land, and you cross the street and you have another piece of land. It doesn't make any sense that somebody tells you that your area is 0. Your area is not 0. Your integral from here to here is 0, but your area is double that here. So in this section, once you hear the word area, it means, well, actually the physical area. And we will learn how to calculate this area now without going into the special example here. Am I clear, Ya Shabab, to you? So what if you have the area, what you need to do, you need to put the absolute value from a to b on the function itself, yes? So we are interested in just turning this function into a positive thing. Yes, is that okay, John? Fine.
Yes.
Yes, fine.
Okay, fine. So let me just recap now. If I have a function, please listen to me very carefully. You only need 1 minute to understand this subject. Suppose now I have a function here and I have another function here. So this is f and this is g, and I'm interested in finding the area between these two curves. So this is a and this is b, and I would like to find this area here between them. So what I will do is the following. I will just take a strip here, a rectangle. Okay, and if you look at this rectangle here, it has a width of what? Of a dx. Is that okay, Asham?
Yes.
What is
Yes.
this value here? What is this value here?
F of x.
F of x. So this is at an x location. So let's say that this is x, and the width of that is delta x, and therefore this is what? This is g of x, correct?
Yes.
So if you take that strip out, so this is dx, and this is actually f of x minus g of x. Is that okay, Asham? So it's the
Yes.
top function. And what is the area of this rectangle here?
Dx multiplied by
Exactly, that's it. Multiplied by the x. And now how many rectangles do you have here?
infinity.
Yes, you have plenty of rectangles, and you want to add them. So you want to add this rectangle to this rectangle to this rectangle. What is addition in our language?
Integration.
Exactly. So you want to collect them in this direction from A to B. Is that fine, Asham? Do you understand what I'm saying? So actually you're calculating the area of one rectangle and you put an integral sign, which means that you will add them in that direction, in the x direction. That's all. It's as simple as that. Okay, let me give you a different situation. Suppose now you have this function, which is f, and this is a g function. Okay, and I want to find the area. Okay, let's say that this is a and this is b between them. So what am I going to do, Yashabam? Okay, I'm going to get a rectangle, yes or no? So this is a rectangle.
Yes.
Okay. And this is what? This is just x at any given x. What's the width of this rectangle?
Delta x.
Delta x, exactly. All right. Okay, so I am interested in finding the area of this rectangle. So what's the area of this rectangle?
Same as before. F of
Yeah,
x
with
to
f of x, which is the top minus the bottom function, all right, multiplied by the x. Now you say that this function g is negative. Yes, we see something like this. This is, let's say that this, please listen. So this is 7 and this is 3. What's the height of this, Shalom?
4.
Is 4. Now this is 7 and this is 7 and this is minus 2. What's the height of that?
9.
9. How do you do this? 7 minus whatever the bottom function is. So 7 minus is just plus 9, correct? Right? So it is the top, yes, minus the bottom function, correct? Always, it doesn't matter. The minuses are going to fix themselves up, right? So if you want to find the length of a column, it's the top level minus the bottom level. We understand this, yes? Okay, fine. And this is exactly what we did because f is on top. So it's f minus g, basically. That's the height. And we multiply this. This is the width. Now I want to take these rectangles. Look at these rectangles up. So I have a rectangle here. I have another rectangle here. I have a third rectangle here, fourth rectangle here, etc. until I reach what? I reach the end, yes? Okay, so I want to collect these rectangles, correct? How do I collect these rectangles? So the first rectangle starts from here, the last rectangle starts from here. So I am going to add. Add means what in our language, Shimon?
Integration.
Exactly. So I'm going to put an integral, and that integral should go from A to B. And this is the area between the two curves. Fine. Here's another situation. Suppose that I have a function, here, that this is f, and I would like to find the area underneath between the x-axis and this function. What am I supposed to, which means that I'm interested in finding this area. How am I going to do this? I have the same process. I have a rectangle. I drop this rectangle here. All right. Okay, let me find the area of this rectangle. What's the width of this rectangle?
Delta X.
Dx, yes. What's the height?
F of X.
What's the top function here?
X-axis.
Yeah, which is
0.
X
0
equals 0.
minus f. You see that? It's the top function, which is a 0 function, and this is f. So this is y equals 0, and this is f, yes? So if you want to find the height of that, it's the top function minus the bottom function. So it's a 0 minus f, and therefore you have it from a to b. Is that fine with you, ya Shabab? The top function minus the bottom function, and the top function happens to be the x-axis, which is y equals 0. So you shouldn't panic. So we are doing what here, ya Shabab? We're doing the area, yes? We're not doing the integral, we're just doing the area. Is this example okay, ya Shabab?
Clear.
Okay, all right. One last thing. Suppose now you have a function that goes like that. So this is a, and this is b, and this is your f function, and this is your g function. And I want to find the area between them. You see, finding the area between them, this means I want to find this area, and I also want to find this area. Right? I cannot do it in one shot. Yes, you understand this, yes? Why? Because the top function and the bottom function change here, yes? How am I going to do this? I will find the intersection, correct? And let's say the intersection takes place at C. So what is the area here? Okay, so it will be the integral from
F minus G.
it
A
will be
to C.
from A to C of what?
F
Of
minus
f minus g dx plus the integral from C to B of what?
G minus F.
G minus f. Is that okay? We're fine. So this is supposed to give you the area. If you are interested in the net sign area, the integral, you want to integrate, for example, f minus g from a to b, this may give you a negative number. We're not really interested in this. That is going to just take pluses and minuses. Now, but this integral will only take positive areas, physical areas, pieces of land, if you wish. Yes. Okay, fine. So we have what we want to do. Okay, let's just do some examples. And there's nothing new, as I earlier said. You already know this. Okay, the first example. Okay, we find the area enclosed by y equals x squared and y equal x. All right. So first of all, let's sketch them. So this is x squared. All right. Y equals x squared, and this one is y equals x. Okay, when we talk about the area enclosed, what do you mean by that, Ashama? That the area is bounded. If you are to choose this area, then this area goes to infinity. Yes or no?
Yes. Yes.
So we're not really interested in that because we know it's infinite. And if you choose this area, then this is the same thing. The area is infinite. We are not interested in this. So actually, we are interested in this area. Because this is bounded. So the first thing to do here is just find the points of intersection. So we will work on the intersection. At the intersection, you know, x is equal to x or y is equal to y. This is what we mean by intersection, because at any given point, for example, this or this point here, x is the same as x, y is the same as x. Okay, so we take the two equations and we say that y is equal to y, so this is what we get. So this is x squared minus x is equal to 0. X is x minus 1 is equal to 0, so x is equal to 0 or 1. Now if you cancel the x here, you will lose one of them, right? Because that's already a 0. So this is what now? This is 1. All right, Shabab? Okay, so now I can magnify this a little bit. This is okay. All right, and this is already 1. Yes, this is 1. Okay, where this is y is equal to x, and this y is equal to x squared. Now my red color, then I have what? I have my rectangle. That's the safest thing I can do. And I would like to find the area of that rectangle. What's the area of that rectangle, Ashabam? The top function. The top function.
X minus x squared.
X, exactly. Is the top function minus the bottom function multiplied by the width of that, which is what?
Dx.
Dx, and then I have to run all these rectangles from where to where?
From 0 to 1.
Okay, let's see these rectangles. You see these rectangles? Okay, they go from 0 until 1. All right, so this is x squared over 2. I'm not going to do integrals, Shabab, but this is yani khalas. So this is like 1/2 minus 1 over 3. This is a 6, and this is 1 over 6. All right, so that area is 1 over 6. Okay, easy. Right. So as we said that if you want to find the area between two curves, A to B, then you have to put f minus g within absolute value. This is equivalent to what I said before. This is the same as top minus bottom. That's it. Very much the same, yes? Right. Okay, so let's just take another example. Okay, we have y equal cosine x, and y is equal to sine 2x. Okay, and this is from 0 to pi over 2. Okay, so let's just plot them. Right, so this is the cosine function, and this is pi over 2, and the sine function. Okay, let me choose a different color. Goes like this. This is the sine function. Right, and now I want to find the area between them. I'm sorry, this is the sine x. I want to have
2x.
It's 2x, yes. So this is yeah, this is not the so sine 2x has what kind of period, Shabab?
Pi.
Pi, yes. So at pi over 2, it will just finish one. So
half
it has
period.
Yes, exactly. It has to go like this and come back as such, because now it will continue a period here. Yes. So this is it. Yes. So this is y is equal to sine 2x, and this is y is equal to cosine x. All right. So now I want to find the area between them. So it means that I really want to find this area, and I want to find also this area. Make sense, Asham? You understand why we have that? Because the sine has this shape, but because it's 2 here, now then this is pi, and therefore this is pi over 2. It's not 2 pi and pi. It's pi and pi over 2 now. Okay, so I need to find what, Asham?
The intersection point.
Intersection. So intersection now. Intersection means cosine x has to be equal to sine 2x. What does that mean? It means cosine x is equal to 2 sine x cosine x, right? Which means that if I bring cosine on the other side, it will be cosine, right? It will be 2 sine x minus 1 is 0. You agree, Asham?
Yes.
Okay, so either cosine x is going to be 0 or sine x will be half. Yes?
Yes.
Okay. If cosine x is equal to 0, then x is equal to what? Is
Pi
equal
over 2.
to over 2, etc. And some other values we're not interested. And if sine x is equal to 1/2, then x is equal to pi over 6. And some other values also. Yes?
We don't
Yes?
need. I don't
Yeah,
need
we don't need that. We only need this. Yes? Pi over 6. Okay, fine. So I have it now. It's pi over 6. Let me
Mr.
just. Yes, sir.
How do you do the first step?
Which one? This one?
No, the second one. The
This
third one.
Oh, I put the cosine here and I took it as a common factor.
Oh, okay. I
Yeah.
guess. Yes.
That's it. Yeah. Okay, so now, we have this, and we have not the best one. Okay, so this is the cosine, and this turned out to be pi over 6. Okay, so now I will just have a strip here. What's the area of that? So the area is the integral from 0 to pi over 6. Agree?
Yes.
Yes.
What's the top function?
Cosine.
Cosine x minus sine 2x.
Okay, very good. Now plus. Now I have another rectangle, and let me just do a blue one here. This is the other rectangle here, and this second region, which means this is from pi over 6 to pi over 2, which is here. Yes. The top function now is what?
Sine 2x.
Minus cosine x dx. I will not do the calculations, Ashab. This is quite trivial, and you'll see that this is 1/2. Yes. All right. So now we have this area plus this area is just 1/2. Okay. So that's easy. So I see that the interesting thing here is that you identify where you want to stop really. Those limits of the integral. Okay, here is another one. Okay, let me just maybe I can show you what will happen here if in general. So let's see that okay, let's see, this is open with all right. So actually this is the integration process. This is finding the area process, and I have all right, let's just okay, this enable that. Okay, so this is the process of finding the area. Suppose that I want to find the area between the blue function and the green function. So what I do basically, I just choose this is my rectangle. You see the red rectangle here, and then the process of integration is nothing but collecting all these rectangles. You see those rectangles up? If you collect them, what happens to the process? You actually get the area, because these rectangles are going to fill up your area. Do you understand what I mean by when you put an integral sign? Actually, we are adding the areas of each of these rectangles. So the idea is just to find the area of one of these rectangles. That's everything you need, and this is what you will see with volumes, surface areas, etc. We will take only one sample, which is this now, the red color. Let's see. Let me just pass it on. So in a arbitrary position. What do you mean by arbitrary position? I mean, you shouldn't put it on the end or the right or left, etc. Just any position within the area. So this is the position of an arbitrary position. Find the area of that rectangle and then see where it moves. It moves from the extreme left here to the extreme right here, and these are the limits of integration. Is that idea clear to you, Ashok?
Yes.
Okay, so this is the integration process. I mean, there's nothing interesting about it, except that you really have to understand that you are not doing nothing but adding the areas of rectangles. That's all. Okay, I want you to find the area. Again, I don't want to spell out the problem altogether. I want you to find the area between these two. Please listen to this example very carefully. Okay. Now, if you look at these two curves together, you see the first curve here is x is equal to 1 minus 1 squared. So this is a sleeping parabola actually. Yes. How does it look like, Asham? If y is equal to, let's say, if x is equal to 0, then y is equal to plus or minus 1, and x is going to be maximum of what? Asham, can you tell me? If x is equal to 1, what will happen?
X equal to 1.
If x is equal to 1, this is going to be 0, yes?
It's maximum, I mean.
So this goes as such here as 1, right? And how
Yes.
does it go?
To the left.
Yeah, that's it, yes? Quickly, yes? No, not the best one, right? That's it, yes? So this is 1, right? So this is x is equal to 1 minus y squared. And this one is also a sleeping parabola, but the vertex is to the left, yes? So the vertex is here, and it goes as such. We also join here. So this is x is equal to y squared minus 1. You see that, Asham? Is that okay? And this is the area that we really need to find, this area. What's the problem with this? If you take a strip, okay, a vertical strip, and you try to remove it, well, actually this is minus 1, right? If you try to remove it, then what is the top function here?
X equal to y squared minus 1.
So this is,
The
well,
same
top
function,
function,
yeah.
the top function is x equal y squared minus 1. So you need to get a y. So y squared is equal to x plus 1. So y is equal to what? Plus or minus square root of x plus 1, isn't it?
Yes.
And we look at this here, this top one here is actually the plus x minus 1, or x plus 1, sorry. And this one here, down here, is y is equal to minus, yes? Right? And then you have to stop here, yes? Because now
Yes.
when you pass through this, now the top function and the bottom function will change.
Yes.
Do you understand what I'm saying, Asham? First of all, you have to do this solving the equation, because the top function and the bottom function are different. And now you also have to split here, because now when you pass through this, the top function is not the same as the top function here. The bottom function is not the same as the bottom function here. So they're different. So this is quite complicated. You can do it. But suppose that this equation was much more harder to solve for y. Suppose that you had this, y is equal to y cubed minus 3y plus xy plus 3. Let's say. How are you going to solve for y? If this was a power 13, let's say. So it's not an easy problem to solve for y, so you can find the top function and bottom function. Do you understand the difficulty of this session?
Yes.
Yes.
Okay, so there is another way to do this problem. It's like you see, as I always say, well, there's nothing so special about x and y. Yes.
I think we should just rotate the graph or something like this.
Yeah, exactly. Rotation of the graph. What does it mean?
And
Substitute x by y.
Yeah. So what does rotation of the graph mean? It means that you are going to think of x as y and y as x. Yes.
yes.
Okay. So but why should I rotate it? I can do it here. I can take a horizontal strip. Correct. Yes or no?
Yes, yes.
Okay, let's find the area of that. So what is the area of this? Now, when you have a strip like this is x right, this is x left, yes? For example, this is 7 and this is 3. The length of that is equal to what? X right minus x left, which is what? 7 minus 3 in this case, which is 4. Yes?
Yes.
Instead of being a top bottom, it will be right and left. So what's so special? Nothing. See, all right, so what I'm going to do, and I'm going just to find the length of that as what? As actually right minus left. So what is the right x here? And what is the left x? Okay, so x is equal to what here? The right x.
1 minus y squared.
Yes, it's 1 minus y squared. This is the right x, x right, yes? Minus x left. What is x left here?
Y minus y squared.
Yes, y squared minus 1.
Yes.
Isn't it?
Yes,
Right?
yes.
So what is this? This is the length of rectangle, isn't it?
Yes.
And what happens if I just multiply this whole thing by dy? Exactly, because now this has what kind of width here? It's a dy. It's not dx. It's not just like this, where this is a dx. Yes, it's just like that, and that is nothing but a dy. So that's the dy, and I'm integrating with respect to what? I will add all these rectangles now, correct? So these rectangles are going to go in this direction, yes? So I have to put an integral from where to where? From this point here?
From -1 to 1.
And this point here. And this point is actually -1, and this is a +1. You can find it. That's the intersection, which means that when x is equal to 0, then y is plus or minus 1. That's it. So this is from -1 to +1. And now you look at this problem. You see that this is very simple. So we're doing that, you see, in a very, very simple integral. To the contrary of the previous one, which would have required us to solve an equation and then do all kind of splitting, etc. But this is in one shot, and this is easy. Now, if you don't like this, just rotate your screen now that you are watching me, and you will see that this is exactly the same problem if you replace x and y. Yes, exchanging them. Put x as y and y as x, so this is the same problem, and you will only have to rotate the picture, but you don't have to. See, instead of taking a vertical rectangle, you take what in this case? A horizontal rectangle. I'm not going to do integrals, Shabab. These integrals are extremely trivial. All right, Shabab? Okay, fine, fantastic.
Mister, can't
Right.
we assume it's a circle? It's a -1 and 1. And
No, this is not a circle. No, these are not circles, yes?
no,
These
but
are
from the graph, because they have the same. It goes from 1 in
but
the
this,
y direction and the x.
no, but this is not a circle, yes? This is yes, it goes from 1 to 1 here. Okay, this is 1, this is 1. You can go from 1 to 1 by so many ways, yes?
Yes, but if
Well,
I
that's
get
not,
stuck in an exam, can I just approximate using the circle?
يعني ما شاء الله على ايش التفاؤل يا ابني الله يرضى عليك. يعني you should be more optimistic than this. You will be fine. I don't understand why you want to complicate your life. You'll be fine. Okay, just do you understand what this is?
Yeah.
Okay, that's it. That's
But I have a question, Doctor.
Yeah. Yes, sir.
I think I wanted to check, is the signed area will be 0 in this question or not?
No, because what we're doing is again the same thing, because it's the right minus the left. Yes.
Yes. Oh, yes.
So,
yes.
so the length will always be positive, correct?
Yes. Yes.
So you don't have to worry about that. Yes. Okay, fine. And if you have a velocity, this is a velocity, which is kilometer per hour, right? And you have car A. This is car A, and this is car B. Now, if you calculate the area between them, from let's say up to this time, yes? Or let's say up to this, let's say T0, up to T0 or T star, let's say. Let's just leave that. It's a T star. Okay, let's calculate the area under between these. What's the area, Shabo? It will be the integral from
minus
0
B.
to T star, correct?
Yes.
Yes, and you take a strip like this. It will be the velocity of A minus the velocity B, yes? This is
Yes.
this is the X. طيب. Okay, let's just split that 0 to T
Or
star.
dt maybe.
Sorry?
Maybe dt.
Yeah, dt, I'm sorry, yes, of course, yes, thank you. Right, let's see, so this is VA dt minus 0 to T star, and this is a VB dt. So this gives you what? Distance traveled by car A, isn't it? Yes?
Yes.
Yes.
And this is what? Distance
By car B.
traveled by car B. So the difference is what?
It's the difference of
The
distances.
distance between A and B.
Between the
After
two cars. Two cars, yes. So if you just integrate that, so you and your friend travel to Riyadh and you have a difference in speed, yes, right? And after some time, then if you integrate this and you integrate that, that should give you the distance between you and your friend. Make sense?
Yes.
Okay, fine. The last problem, this is just a small comment. The last problem says the following: for what value of m, this is just a fancy problem, do y equal mx and y equal x over x squared plus 1 enclose a region. Is it possible that they have a region in between? Let's see. Okay, and then find the area. Find the area of the region. Okay, let me just tell you what I made a small animation for you this morning, and let me just show you what we mean by this problem. This is exercise in the textbook, by the way. I just did it here at the bottom. Yes, look at this. We have this function which is mx, right? Okay, and this function which is x divided by x squared plus 1. So this is what we've just been talking about, yes? Okay, Shamam? So you have this function and this function. When I say, when do they enclose an area? When do they enclose an area is, so this is the first function, which is the x over x squared plus 1. And the mx is, let me just show you the mx. Okay, this is the mx, the green one. It's a straight line that passes through the origin, yes?
Yes.
So there is a region here. So you look at it, not this region. This is an infinite region to the right, and to the left, extreme left, that's an infinite region. I'm talking about the yellow region in the middle. So there is a region between the blue and the green for a certain m. If you change m, which is the slope, yes, is m the slope or not?
Yes, it's the slope.
Okay, all right. So this is now at a given time here, they will start losing the region. There will be no region between them, right? So we want that, if we want that exact m, so that they will have a region, right? So what is that m at which they stop to have a region? Okay, you can see that if m is positive, they have a region. If m is negative, what happens, Asham? Okay, let me just do this for -2. Okay, now m is negative. Look at this here, Asham. M is negative. Do they have a region?
It's all infinity.
It's infinite, so we don't have a region enclosed. Yes. So now this is 0. Okay, let me just go back a little bit. Now this is negative, no region, and this is 0. Okay, now you look at this here. Now it will become 0 now. Now this is 0. You don't have a region. Now again, if it is positive, they will start having a region, but not all. Yes, because there will be a time. There will be a time they don't have a region anymore. Yes, see that? Now they will stop to have a region here. Yes. So from M equals 0, which is in this position here. Okay, let's see. Horizontal. And then up to this value of M, they will have a region. After which there will be no region. You understand what I'm doing, Ashama?
Yes.
Yes.
Okay, so if they have a region, what should happen? They should have an intersection, correct?
Yes.
Other than the 0, yes. So there's this graph here, and there's the other graph. If they have an intersection here, of course they will always have an intersection at 0. But if they have an intersection here, this means that they have a region. Otherwise, they will not have a region. So what do? We just check the intersection. So intersection means mx is equal to x over x squared plus 1. Okay, Shama? What does that mean? Means we have mx cubed plus mx is equal to x. Tamam, Shama? Or
Yes.
mx cubed plus m minus 1 times x is equal to 0. Now we'll take x as a common factor. So this is mx squared plus m minus 1 is equal to 0. So what are the intersections? X equals 0 or x squared is equal to, on the other side, minus m minus 1 divided by m. Is that okay?
Yes.
Or in other words, 1 minus m divided by m. So this is x squared is equal to 1 minus m over m. And this, since this is x squared, this has to be greater than or equal to what, Tashama?
To 0.
To 0. When is this going to be greater than or equal to 0? Okay, we have a sine curve, yeah, so sine graph. So when m is equal to 0, or when m is equal to 1. So if m is more than 1, what will happen? This is 1. We're checking this, yes? If m is more than 1, so this is negative, correct? If m is
Yes.
equal to 1, this will be 0. And if m is between 0 and 1, this is going to be what? Positive. If m is less than 0, this is going to be negative.
Yes.
Yeah. So now this is going to be true if m belongs to the interval 0 to 1. And 0, you will only have the 0 solution, yes? All right. So actually, you need this m to go on the open interval from 0 to 1, because they will not enclose the region. The region is going to be 0 at the end points here. So now if m belongs to the interval from 0 to 1, then yes, we have a region. Otherwise, we will not have a region. Does that make sense to you, Asham? No. How do you do that? We just took the intersection of these two curves, and we try to find the intersection. We found that the intersection is either at 0 or at when this is equal to x squared. Yes, 1 minus m over m is equal to x squared. Since this is x squared, then this must be greater than or equal to 0. And then we found in the sine graph that it has to go between 0 and 1. Exactly at 0, they will barely touch. At 1, they will barely touch. There will not be any region. So m has to be between 0 and 1, so we have a region. Now, therefore, what is the area actually? The area is what?
Doctor,
Yes, sir.
does the quiz start now?
No, just give me a few minutes. Just
sorry.
Yeah.
I thought so.
Right. So so the area is what? Is going to be from again. Let me just calculate this. Okay, I will just leave it for you. So this is it. Yes. So there will be a straight line. Sorry, straight line. Okay, now I'm going to have this area and multiply it by 2 because this area is the same, yes? So it will be 2 from 0 to this position here. What is that x? X is actually the square root of 1 minus m over m, yes? Okay, so this is 1 minus m over m. The top function is x over 1 plus x squared minus the bottom function, which is mx and then dx. All right. Okay, if you do your calculations, see that this is m minus 1 minus ln m. And please check this home. All right. Okay, so this, I thought I found this problem at the end of your section. Then I said, then I might want to discuss it with you guys. All right. Again, the idea here is very simple. As well, when you have two functions, and if you have two functions that intersect, it doesn't really matter. All right. See, this is you find where they intersect. You see, this is the top function, and this is the bottom function for this region. This is the top function. This is the bottom function for this region, and this is the top minus the bottom. And you may as well want to do this along the y-axis. It's not peculiar to the x-axis. All right. So can you please open your cameras now, Shalom? Okay. The quiz is going to start at 9:25. Okay. That will open. Please, just adjust yourself in the appropriate position.